Welcome to our webinar on data processing and visualization at scale, with an emphasis on telco use cases. Just to get started, we will start out with introductions. Me and Daniel will introduce ourselves. Then we'll go and tell you a little bit about Apache Sedona, about Wherobots, and then we will look at solutions for telco. And in particular, Daniel has a demo spun up that we put together showing how location data can be used with the Wherobots platform for some common telco use cases. We also have a new integration with a platform called Dekart, a visualization platform that we will be showing as well. And then after that, we'll do closing thoughts and some Q&A. So just to get started, we will do introductions first. Daniel, you want to introduce yourself real quick?
Yeah, sweet. Thank you, Sean. My name is Daniel Smith. I'm one of the senior solutions architects here at Wherobots. I've been here for about 16 months now, but I've been in the geospatial domain for the past 20 or 25 years, working in consulting, working in tech as well. I'm super excited to show you guys some of the use cases and what we've done here at Wherobots. Sean?
Great. Yeah, I'm Sean Knight. I'm also on the solutions side of things. Also come from a geospatial background, although have been in some other areas as well. My actual origin story with Wherobots is I was a Wherobots customer for about a year before joining the team. So I had my own company, and we were actually one of the early adopters of Wherobots. And so I often think about things from the perspective of the customer because I literally was one. And then about probably 6 or 7 months ago now, I joined the team here. I saw what they were building. They were solving the right problems. And so it just made sense to join them instead of just being a user. So here we are. And now I'm a member of the team and I'm presenting to you today. Okay, so to give a little background on some of the problems that we're trying to solve at Wherobots, if you have, let's say the end goal is some sort of spatial intelligence system. So what you want is you want a complete view of kind of what's happening in the world, when it happened, the geographic parameters, how things were spatially related. This is a common need for what's now coming up as a term, it's spatial intelligence. But usually when you need this, you have lots of different inputs. You have these varied inputs. So you have some aerial or satellite imagery or data. Sometimes you'll have GPS or telematics or other ground level data. You'll have some sort of ground truth data from IoT or sensors or even actual manual samples being collected or counts being done. And then you have some added business context that comes into play. And the challenge is often that when you have all these different varied data types coming in, you don't have a unified system for processing them. So you have incomplete coverage, you have delayed intelligence, you have limitations in how you can use these things simply because the different systems don't necessarily talk to each other. And then you can also have skyrocketing costs just because you're standing up different infrastructure to work with different parts of this data pipeline. At Wherobots, that's the problem that we are solving. So we're trying to reach, and we'll show you a little bit of our progress there, planetary coverage for these kinds of location data sets or geospatial data sets, where you can fuse these large data sets much, much faster than you could using traditional geospatial systems or data engineering systems. And then you can also use that added compute efficiency to pursue use cases that would be too costly or slow or have too much overhead otherwise. And some of the questions that you may be asking or that people often ask in these contexts are things like, what are the optimal routes to use for some sort of operation? What is the highest value location? So that could be for property investment. That could be for site selection in industries like retail and restaurants. You might be asking what crops have been planted and what is their health. So that would use a lot of satellite imagery and agricultural use cases. You see questions like what areas or assets have a high risk, be that flood, fire, security, something else. And then also you can ask questions like what impact did some event have? Or, this occurrence happened, what were the results and what were the causes leading up to it? And so these are fundamentally geospatial questions because the way things relate to each other in space always have an impact on these kinds of questions. Okay, so we're going to start with or jump into a poll here. So I will kick that off. And what we're going to ask, let me pull up the poll. Let's see here. Okay, so you should see this coming up in a couple of minutes here, but the question is, what do you use location data for today? Or how do you use location data today? And why Zoom hides the polls, I will never know, but it should be launching now. So you should see it if you are on the webinar on the Zoom version. If you are not on the Zoom version, I'm going to go ahead and pull up a QR code in my browser. So if you are one of the live streaming participants, you can scan this QR code if you want to answer as well. And now, when I looked at this earlier, I believe the people on the live stream and Zoom cannot actually see the results of the poll here, but I'll read them out to you. So we are seeing, let's see, 24, 25 answers so far out of 41 participants. So 60%, 63%. Wow, you guys are very engaged. I really appreciate that. I'm seeing significant use of network quality analysis. So we're seeing several of those. We're seeing asset management is used quite a lot. Making cool maps is up there. So making cool maps is in second place. We've got asset management in first place, network quality analysis in third is kind of where we're ranking. And then we do see some other use cases here as well. So that's great. Yeah, that makes sense and sounds like we're talking to the right audience. Let's go ahead and jump back into these slides. So I'm going to give you a little bit of quick history about Apache Sedona and kind of how Wherobots fits into this. We're not going to get too bogged down in it because we want to get to Daniel's fantastic demo that he's been working on. But we'll just give a little bit of background info for context. And just for the poll here also, I notice we do have a couple of comments for the other options. So one person said footfall traffic analysis makes a ton of sense. That's definitely a useful one. And then let's see here. I hear someone saying I mash up high volume vector data, including FEMA flood zones, major roads, meta population points, Microsoft buildings to develop flood evacuation vulnerability. So that's a great use case and also sounds like a pretty heavy workload. So very interesting. Kudos to you on having a cool use case today. That's actually a really good one. Great. And so we will proceed here with the Apache Sedona. So just of history, that problem of conflating these different data types in geospatial and getting to that spatial intelligence point, that is really what motivated both the creation of Apache Sedona originally and eventually Wherobots. And Wherobots is our company that is Apache Sedona under the hood with some enhancements and improvements. Apache Sedona is an open source project that our founders created. They were both academics at the time, both professors. They created this project as sort of an experiment, and much to their surprise, it actually blew up and was in great need. So you could think of Apache Sedona as Spark, but for geospatial. And so as this project grew, it's grown today to 300 plus vector and raster functions for doing these geospatial operations. As this project grew, we saw more and more adoption and more need in the industry for some sort of managed or supported version of it. Today, Apache Sedona has greater than 50 million downloads, tends to have a pretty significant growth rate. It's used by some major companies in different sectors, and it has over 140 contributors across the world. So based on the success of Apache Sedona and the signal that we were getting from the market and from the open source community that this is something that people need, the founders of Apache Sedona built Wherobots. So this is what Wherobots is. We are managed Apache Sedona, but far more enhancements. So we show speed, scale, flexibility, and performance above and beyond not just the other solutions that you see in the market, but also above and beyond what you would currently get using the open source Apache Sedona. We do still fully support the open source Apache Sedona, though. So we are an open core company. That means that if you started using Wherobots and you say, man, I really love the speed, I love the scalability, I'm a huge fan of everything that I've built in there. I just really don't like that Sean guy, so I don't want to do business with them anymore. That's totally cool. You can take all of your workflows, pull them out of Wherobots, pop them into Apache Sedona, and go back to the open source version. So we do not believe in vendor lock-in. We want you to have options. Um, Works on vector, raster, and tabular data. So that all can be done within one platform. Earlier, I was talking about kind of the challenge of doing raster in one platform, vector in another platform, having to figure out how to merge and combine these, maybe having multiple sets of infrastructure that you have to stand up to work on these. Whereabouts solves that problem by putting it all in one place, as does Apache Sedona. And then just quick obligatory performance slide. So I was saying that we do have some performance improvements even above and beyond what we show with Apache Sedona. This is just kind of what we're seeing here. So in some more traditional data warehousing architectures like BigQuery and Snowflake, they can do some spatial operations. Often they have a limited number of spatial functions. But oftentimes with a lot of these solutions, the spatial side of things, the geospatial capabilities were added as an afterthought. So they started as a data warehouse, and then they said, hey, we also need to support spatial. So let's tack that on. Apache Sedona and Whereabouts were created from scratch to support spatial as a first-class citizen. And so that is why we see some of these large performance gains over traditional solutions. Okay, let's do one more poll. I should be able to actually find where the poll button is faster this time. So I think you should be seeing it in just a moment here. Let's go ahead and end the first poll. And I should be launching the second poll now. And here is the QR code that you should see coming up. So if you are one of the live stream participants, you can scan this QR code and pop in your results. If you're on Zoom, then you can just do the poll directly. Okay, so I'm seeing some results here. Looks like a few people are still filling it out. But the question is, just to jump in here and kind of talk through it, how are you processing geospatial data today? That is, if you are processing it. So a lot of people tend to use Postgres or PostGIS for this. Very traditional solution, totally makes sense. GeoPandas, personally, I'm a GeoPandas guy. I used to use GeoPandas a lot before I was using Wherobots. GDAL, Dask, Google BigQuery, and then we also have Apache Sedona, Spark EMR. We do have a couple of Wherobots customers showing up, and then we've got the something else category. And if you want to pop your something else in the chat, feel free, no pressure. But happy to see what you guys are using. And it looks like that's about the results. Actually, really good. Like 63% of you actually filled out the poll, so that's awesome. Thanks, guys. So we're seeing, it looks like first place is GeoPandas. And then second place is actually something else. Makes sense, captures a lot of categories. And then coming in at third is PostGIS and Postgres, which of course also makes sense. We see a lot of that one historically. And we do have a handful of people using Apache Sedona, Spark on, EMR, Databricks, some sort of other platform. So that's great to see. I'll end poll. It looks like there's a share results button. So I assume you guys can see those results now. Daniel confirms. Thank you, Daniel. And great, let's jump back into the slides. And this one's just a little bit of a diagram. I mean, it's a little bit redundant with some of the things that we've already talked about, but just how you can draw in different types of data stored in different places in different ways into our platform. You can do data processing. Optionally, you can connect to AI platforms, AI tools, as those are useful. And then, of course, you can write back out to some of your common data formats, data lakehouses, data warehouses. And then personally, I always used a lot of storing my data in a Iceberg table in S3 when I was a customer. That was kind of where I put everything. But I know a lot of people are, big fans of Snowflake, Databricks, EMR. These are also great tools to use. Okay. Daniel, do you want to actually let's do this. Out of everything on this screen, because these are a lot of our newer and added features, what is your favorite and why?
Oh, mine
I
personally?
want your personal favorite. Yes.
Gosh, I really think that the isochrones are probably the newest thing that I like the most. The spatial statistics stuff that we're going to talk about here in a minute, I think deserve their own spotlight. But the isochrones are such a nice added benefit for doing so many different pieces of analysis across different verticals. I mean, we see it being used in agriculture, in delivery, and logistics, and route planning. Just it's such a fun tool to use and such a nice representation of kind of this distance metric that is so critical for all of these types of analysis. I mean, we've looked at it with telco use cases for drive time analytics. Just it's such a nice, and what's really nice about it is that it's actually very tunable. There's a couple of different ways that you can use it. There's the very classic, like what you see in this image, where it has all of these kind of fingerlings that kind of stick out from all of the various nodes that you can actually reach from your origin point. But there's actually a more simplified version that you can use that runs faster, that is still a high quality representation. It's just nice to be able to have that flexibility where so many tools are like, what's your drive time, what's your location, without any ways to tune that representation. So I think it's the isochrones for sure.
That's funny. I would not have guessed you were going to go with isochrones.
It's a big fan of them.
I probably would have guessed you would have gone with hotspot analysis simply
I do,
because
but we're
of
going to
the,
talk about hotspot
yeah.
analysis in a
Yep.
minute. And so, like, I kind of didn't want to give up the ghost until then.
Well, let's see. Isochrone's off the table. I think I'm probably going to go with the map matching for my favorite. I get, involved in a lot of these mobility data and IoT and telematics use cases. And when you look at some of this, when it's roadway data, it can just be all over the place. And just the variability in the GPS signal makes it hard to figure out where someone was on a roadway. So that's a pretty cool use case right there. Jump forward to the next one. So we also have some AI analysis and image recognition. And actually, Daniel, do you want to talk about this one? I know this one's kind of close to your heart.
Definitely. We've got a couple of different ways that we can perform raster inference. We have a newer product that's raster pipes that's on its way out. Our current raster inference technology it's actually really simple. It's a bring your own model type of inference. You import your model, you import the spec that kind of defines and matches the inputs and the transformers to the model itself. And then you just use simple SQL to call that model. You were either using typically bounding box models, segmentation models, or classification models. And if you see in that text box there, we're using RS text to B boxes. This is actually using the SAM2 model. So we have a few models that we host in-house, SAM2. There's another one that uses SAM and a like an LLM style kind of human prompt to get directly at the information you're trying to extract. We have a couple other models for bounding box detection of like marine infrastructure and solar panel detection. But it's just such a nice way to integrate ML and AI into your larger workflows, right? A lot of these platforms that will do AI or do ML or do the scale processing that we do, either with vector and raster, are frequently independent or take a lot of work to connect all of these pieces. With the Wherobots platform, you're really given like one point of access to all of these great tools to be processing at scale. And so you can go from like this example here, directly running your ML inference, taking those extracted boundaries and then directly integrating that with like population data or other statistics or other geospatial data that you have. And so it's that really blending from your pre-processing, your analytics, your raster inference and your ML, blending that back into decision making with the rest of your stack and your mapping units on the other end.
Yeah, no, that's awesome. That definitely makes sense. This one's exciting for me too. Back before I joined the company, when I had my startup, one of our earliest projects was a raster inference project. So we were doing We were actually building a data product. We were identifying cars and roadways, and then from the center point of the roadway, we could identify whether they were parked on the side of the road or actually driving. And the idea was that we would accumulate a sort of parking density or parking difficulty score for different regions. And this was before the days where Wherobots had this raster inference model built into the platform. So we were doing this ourselves from scratch using segment anything models, and it was a huge battle. And so there are a lot of these features where, as we roll them out as a company, I just always think back and think, man, I wish we had those back when I was working on this. I will also I just actually opened the chat here because it looks like I've fallen a bit behind. I did want to mention that there is a comment that the polls should be where you can select multiple because a lot of people are using many of these tools all at once. 100% agree. I definitely take the note, and we will do that for next time. I was looking at those and thinking that I need to go down the list and select everything as well. And yeah, we didn't include Esri in there just because we have a lot of overlap with Esri, but also in some ways we don't because we tend to be more focused on the data engineering use cases. But that's a good point, and we should include Esri in the future. Great. And we'll go from there. Okay, so we have another poll, and this one, once again, probably would be better if we could select more than one answer, but I think it's still set to select only one answer, so we'll save that as a note for next time. But let me go ahead and launch it here. So we're going to go back, going to launch poll 3. And then we'll bring up the QR code for anyone who is on the live stream rather than the Zoom call. And the question here is just what challenges do you have working with spatial data today? I would also accept challenges you've had in the past or, challenges you've heard coworkers complain about, all relevant and fun. And yeah, definitely I could even thinking back to my pre-Wherobots days, I would probably select multiple of these as well if that were an option.
I think they will just include it all also, like especially when it comes to the what are my problems with spatial data? Just all of them.
Yeah.
Frequently see so many different points, right? Like there's so many points of failure in these, and doing it with large scale data is definitely a challenge. I think
Yeah.
one of the
And
best points about using Wherobots, honestly, is just the speed at which you fail, right? Like it can take so long to run a geo process only to realize that like this is not the type of relationship that I wanted to encapsulate, or these different factors really don't like paint the picture or get to the result. And you just spent, a half an hour a day running a long process just to find out that it was actually wrong. Being able to do the same analysis and have the same failure, but have the same failure within 10 minutes allows you to iterate that much faster within your platform and kind of get to like the actual answer that you need in the end.
yeah, I mean, I think really the point you make there about iteration is key. Like a lot of people underestimate how much of this is figuring out what you're supposed to be doing by doing.
Yeah. Yeah. And to that same point, I mean, that's why it's so valuable to be able to work with the traditional like pixel-based analysis through the map algebra functionality that we have, or all of the RS functions that we have, in conjunction with all of the ST functions dovetailing right into the ML stuff, right? Like being able to fail fast in one area so that you can iterate faster in all areas. Whereas like here, like we can fail fast in all of them, right? We're gonna, not succeed in these, but that allows us to iterate across all three dimensions of this analysis stack rather quickly.
Well, and I mean, that's also why it's so important to make it so it integrates with different data types, can operate on your data where it is. If you spend half a day or more just getting your data cleaned up into the right place so that you can do your analysis on it, and then once you start the analysis, you discover, okay, maybe this analysis isn't quite what I need to do. I need to do something different. Your iteration and feedback is slowed down a whole bunch, and you get bogged down in prep work, even though the actual work is where you really learn where the value is. Cool. It looks like the poll is about done here, so let's go ahead and we'll end the poll and share the results. And it looks like I'm seeing, so for challenges people are currently facing,
Scale.
We've got a tie, yeah, between current workload doesn't scale and it's too hard to productionalize. I would also say a lot of these problems are correlated, right? So if you're seeing one, you're probably seeing the other, is what it comes down to. Um, Too difficult to do what we need to do. Comes in at, well, I guess that's like fourth or fifth place. Can't work with vector and raster data in the same platform. Yeah, that gets exactly back to what you said there, Daniel.
Yeah.
Something else, so we'll see some things in the comments here. And very, very big congratulations to this one person. No challenges, spatial data is easy. That sounds awesome. I'm happy there's at least one of us that feels that way.
Awesome.
Cool. Uh, so we'll wrap that poll up and I'll keep an eye on the comments here. It looks like there are a couple of comments popping in. Let's see. Oh, wow. Really good conversation actually going on here in the comments. I know we've also got a couple of Wherobots participants who are on the call. So if you guys want to answer some of these comments and engage with these folks, please do. I don't think I'll have be able to read through all of them here. Um, but we will jump forward. Okay. Fantastic, everybody. So we'll just keep going here. So this is actually, Daniel, do you want to talk through this? Because I know this one's one of your
Yeah.
creations.
Yeah, definitely. So I think for this, we're really just trying to highlight how well telco use cases blend with the Wherobots platform. Wherobots is able to consume, you know, all of the common data formats, right? Whether this data represents devices, and their quality of metric or quality of service metrics there, the antennas, the towers, how the antennas and the towers relate to each other, Wi-Fi access points, like whatever those are, like we're able to either directly ingest those from outputs from databases, right? Consuming CSV files, GeoJSONs, shape files, or lots of other geospatial formats, or even like connecting to your existing data stores, right? Like we're able to directly integrate with Unity Catalog. We can directly integrate with your S3 buckets and have those as kind of a storage integration, as a first-class storage layer within our platform. All of this data can be ingested directly at scale with Wherobots, and we're going to walk through a demo here in just a minute that kind of highlights bringing in vast amounts of GPS data, running large-scale aggregations, and then doing, KNN join and advanced spatial statistics on there. I think the other parts about this are just kind of the processing side. Like I said, all of the spatial functions are expressible either as pure spatial SQL. You can use them more as like a data frame API. So for the folks who are answering, GeoPandas is really prefer how I do my processing. The Spark framework in Sedona has a data frame API that goes along with it. For the folks who are more familiar with Postgres or SQL raw, you can use SQL directly within Sedona as well. That data can then be distributed through various ways, either through the Iceberg catalogs that we support, exporting it out to Parquet or GeoParquet, GeoJSON, or even cutting PM tiles. And so if you guys consume your discrete geospatial data in vector tile format, we're able to create PM tiles, which is a kind of a structured archive version of vector tiles. And that can then be loaded into various BI tools, data tools, or any other type of GIS consumer like we're going to see here in a minute with Kepler. Thank you, Sean.
Yeah, no, fantastic. Appreciate that. Trying to
Yeah,
answer a couple of the comments here. Just want to say I appreciate how active you guys are here. So I'm gonna stop sharing, give it over to Daniel, and Daniel can take it away with the demo.
awesome. Thank you very much, Sean. Let me do this. All right. So real quick, just a kind of a brief overview of Wherobots' main interface. When you join your organization and start your organization, you're presented with this lovely notebook selection page. We have various ways and various sizes of notebooks that you can select depending on your processing needs. So everything from these small little tiny workloads that are available in our community edition. So you can sign up at Wherobots for a free community edition that'll give you access to this smaller instance here, all the way up to these gargantuan 2XL that are for, multi-layer processing at a global scale. So that's kind of the main interface here. We have our main data hub here. This is where you can look at all of either the hosted storage that or the managed storage that comes with the organization. All of these are S3 buckets that are attached to external organizations, so you can bring your own. You don't have to import your data into Wherobots. Like we really try to bring our compute to your storage. Additionally, this is where you would add your Unity catalog integration as well. You can kind of manage your storage through our storage page here with our integrations and monitor your job runs as well. And so we do offer automation techniques through Airflow and through a full featured REST API. So if you guys have reoccurring jobs or when you need to automate processes, those tools are available to you natively within the Wherobots platform. We're going to jump directly over to our actual use case demo. Here, we're doing a quality of service assessment, looking for hot and cold spot detection. And so what we're going to do is we're going to process about 20 million GPS points. We're going to generate and aggregate that to about 30,000 H3 grids that cover a little over 164,000 square miles in California. All of this actually runs in under a minute for about $3. I'm going to kind of jump in here. This is our AOI that we're working with here. So just the great state of California in its entirety. And reading in this data, we're going to do a couple of transformations, right? We're going to first take the raw data that was delivered in a CSV format, convert that directly to a point here, and then rewrite that and order it based on a spatial index. And so this is less of the spatial index that you would think of when you're like using PostGIS, like a gist index or a B-tree. What this does is actually reorders the data on file according to a space filling curve. This allows for spatial filter pushdown or predicate pushdown to be facilitated at a high rate of speed. So if you think about it, you've got 20 million points that cover the entire country, right? How those are ordered in the file when they're partitioned, like in Parquet files, has a big effect on how the file pruning and the query planner works, right? So if you have all of your data spatially come back within the files, the readers can actually look at the bounding box metadata to determine if any of the geometry actually falls within our AOI. We're going to do kind of our second and third transformations here. Simultaneously, we are going to be creating our H3 grids and aggregating at the same time, right? So using our H3 functionality, you've seen this in lots of other places. Lots of other tools have H3 functionality, and that's frequently the extent of their geospatial, functions. Here, well, we support all of those ST functions. We have another like 180 or 190 that go along with it. So in this, straightforward set of code, we are generating those H3 cell IDs based on the geometry here and doing our actual rollup as well as our spatial filter pushdown, right? So in one chunk, we are only retrieving the data that we need to within California. We are generating the H3 cell IDs for each of those that they fall within, and then we're aggregating them right back to the top, and we're generating that geometry from that unique set of aggregated H3 cell IDs. Now, I'm going to pause for a second and pull up the chat. I want to make sure there's any questions here.
There's a lot of good conversation going, but no questions specifically about the demo that I've seen so far.
Awesome. Just feel free to interrupt if you guys have questions. Sean, please help keep me honest on that one.
I'll keep monitoring and I'll bug you if something comes up.
Appreciate it. You can see here like what the results are of this, right? This is just a cache and account. So we have a little over 3,200 H3 cells. You can see our statistics are kind of just shown here. And if we look at our map, we can use our inbuilt Sedona Kepler integration to kind of get an idea to make sure, that we get what we would expect, right? This is, again, one of those instances where if our H3 cell size was wrong, a long running process would take us a lot of time just to get to the realization that, hey, my grid cells are too coarse or my grid cells are too fine grained, and I need to do something else. And so this is one of those instances where, being able to run this analysis on all of this data in 15 seconds really allows us to iterate faster and kind of tailor the analysis for the need at the time. And here is our hotspot analysis. And so if you guys aren't familiar with the Getis-Ord Gi star, Getis-Ord Gi star is a geospatial statistic defined for generating hotspot and cold spot analysis. So rather than your typical like clustering algorithms that just look for spatial clusters, this algorithm actually looks for clusters in both space and attributes. And so when we look at this, we're going to run our hotspot detection on two of our metrics, our latency, our download latency in milliseconds, and our upload latency in milliseconds. This is going to tell us where we have high values of latency clustered together spatially. This will tell us that some of these areas need to have further investigation, which we're going to look at in just a second. So here we're defining our search radius based on, it's about 2 degrees, or the 002 distance is in degrees, which maps out to about 2 adjacent cells or 2 adjacent rings within our H3. This can be tuned depending on your industry and your logic, right? We try to keep as many of these parameters with valid and like really tested default values, but then they're all able to be tuned to match your specific use case.
And Daniel, I've got a question here that's coming up in the comments. They're saying, Alexei is asking, is create spatial index only available on Wherobots and not on OSS Sedona?
Yeah, that command is specific to us, and like it does use that specific system call. And I believe that is part of the Wherobots offering as well, using those Hilbert curves. But we can double check that and make sure that is the case. But I do believe that the rewriting of that based on that curve is specific to the hosted version. Awesome.
And then just for context, like what could you give an example of why the hotspot analysis and traditional clustering are different? When you say hotspot analysis uses an attribute, would this be like, so if we were thinking about like hotspots in a like wildfire after wildfire, would that attribute be something like temperature?
I think that hotspot could be less of like your actual temperature there and more of like a high value. So when I say hotspot, this is actually a hotspot or a cold spot, right? So you have a clustering of high attribute values or a clustering of low attribute values. When you run this statistic, you get your actual, like your z-score, which tells you the extent to which this is there, but you also get your p-value that indicates whether this is due to like random chance or not. And so both of those are captured here, and we can actually take these results and map them based on their z-value. So here, where this is our upload latency here, and you can see that we have these very high z-scores coupled with, these are moderate p-values, but there's some areas, yeah, see that, yeah, e to the minus 10. So these are very high z-scores with very low p-values, indicating that these hotspots are not due to random chance and that they're actually part of the system here.
So it shows that these are clusters that have a value that differs significantly from the background or from what's around it. Is that right?
Yes, and from neighboring adjacent cells. So this is like, these are all like very intense hotspots here. I think this is another good one here, where you see this cluster of hotspots here, these high z-scores with low p-values. But then out here, you have these cold spots that kind of, border the edge. So this is a very nice representation of a statistically significant hotspot surrounded by these lower latency values here.
Fantastic.
We can kind of overlay that and see the other value here too. This is our download latency overlaid as well. And, as like a data engineer, or as a first brush, analyst, like this is kind of that stopping point, right? Like, this hex Getis-Ord value can then be written out to the database. And that's kind of where like your typical analyst or data engineer would typically stop. But that's not really where the story of this data really ends. On the tail end of this, you would have your business analysts or your other folks that need to do additional ad hoc analysis against the process that we just ran. Those folks might not need a full-fledged notebook. What they really need is like a SQL interface just to kind of interrogate this data. That's where our Dekart integration starts to come into play here. There it loads back up. Our Dekart integration allows you to connect directly to the running cluster. And so you set up a connection here And then once that is ready to go, you can see it's going to start downloading our individual map data. And it allows you to kind of iteratively issue new SQL statements. You can see here that we're actually about to run a couple of additional analytical pieces here. I'm wondering, there we go. I'm going to flip between two to see which one's going to get us there faster. I think for this one, like, it's important to note that these layers, I think the towers are coming in now. Awesome. That this is API access is granted through our use of API keys. And so with the Wherobots platform, it's not just this one interactive thing, right? Like, we do have the tools in place to allow for full automation of these tasks. So whether that's service principals that are dedicated to kind of using the automation tools, or the Python database API that allows you to kind of work with your Python platform and your Python tools as it is. There's even a TypeScript SDK that would allow you to build more interactive tools kind of within the platform. As these kind of get spun up, that's kind of the bulk of this platform here. You're able to sign up and add and persist your connections over time. You're able to add these multiple query windows and use this data kind of interactively as it kind of comes through. You can see it loading up right now.
And this is Dekart. So my understanding, this is essentially a managed version of Kepler GL with some added benefits and integrations with Wherobots and some common data warehouses. Is that right? We partnered with them, and then we have an integration with the team over at Dekart. So
Yeah, definitely.
this is not within the Wherobots platform. This is actually integration through a partnership.
Yeah, exactly. And so we can take a look at this one here. We can kind of exemplify some of this. So we have all of our towers now loaded. So before, we had kind of done our initial analysis, done our hotspot detection based on our devices and their latency. But now we kind of want to get in and add some additional layers. So each one of these query windows actually overlays the individual query frame on top of the map. And so you can see here that we have our individual towers all loaded up nicely. Do this query here, but this is actually pulling in all of the different ones here. And so this isn't quite what we need. We can actually just edit this query here and just retrieve these LTE types here. This is going to take a second. And when that finishes up, we'll also have our G star ready to go. Go ahead and highlight some of these KNN lines as well. So if you guys are familiar with KNN joins, it's the process of essentially joining based on your nearest neighbor, right? Typically, this query is written as a cross-lateral join in most Postgres systems. We actually have a purpose-built KNN join predicate. I'm going to say that again because this is pretty unique. And after all my time in Geo, like running the same type of query again and again and again, this join is a KNN join predicate. There's not a cross-lateral join, having to find and then filter everything out. It is really just based specifically on the KNN join predicate, right? So you can see now we have our Getis-Ord statistics done here. And what we're actually looking for now is we're going to look for all of the two nearest towers for each of our hotspots with a positive z-score and a low p-value, right? That's all that we're doing here. And when we can take this and we can adjust this down, now we can start to say like, oh, for all of these hotspots here, right? All of these, this tower is kind of the common denominator between all of them, right? This is the first nearest neighbor to all of these objects, and this is the candidates here. And so then you can start to like kind of get an idea and an understanding of like, well, which towers are responsible for this low quality of service? How many towers are within a certain distance of here, right? Like all of those kind of ad hoc analysis can be facilitated through the Dekart platform, through writing this type of spatial SQL that we see, you know, all over the board in many industries. And so the same thing happens here. So if we just want to do our towers here. This one's still going to run. It's going to filter down and we'll just see our LTE towers. And this would allow you to then like share this map. You can save it out to your organization. You can export it and the data just like with other Kepler maps to kind of circulate it around your organization. All of the functionality that Kepler gives you, you get with the Dekart integration, plus direct connections to Wherobots and their other first-class data connectors as well. I'm going to pause now. We kind of went over how to do hotspot analysis, ingest the data, do some transformations as well, save that data to the catalog, and then use Dekart in our integration to have some ad hoc analysis, specifically in this case, trying to identify the towers, the nearest towers to each of our hot spots that are statistically significant. I'm going to pause there and see if there's any questions.
I see a question here. It looks like, let's see, does this also work for raster analysis? If big raster files like SAR, I guess if you have big raster files like SAR or heavy satellite images, does this sort of workflow still work?
Yeah, definitely. And so one of the things that's different between open source Sedona and Wherobots is the ability to use what we call out DB raster. And so when you do raster analysis within Sedona, that entire scene gets loaded into memory and has to be pushed to all of these nodes. That can be very costly. I mean, these scenes can be huge. But using OutDB raster and this kind of internal tiling mechanism that we have, you're actually able to dynamically subdivide your large scenes and send those smaller pieces out for analysis. So the short answer is yes, this system works great with remote sensing data, whether that's single band classified raster or multi-band hyperspectral satellite imagery. At that point, we're really just dealing with an array of pixels. May that be from SAR, Sentinel, drones, however that needs to go. And that same imagery works, like I said, with our raster functions as well as our raster inference and raster pipes technology. Cool. Yeah, you can see down here now we have just our LTE towers returned here, and we can kind of pan around the map, save this out when we need to. All of those little bits that you would expect from Kepler are here for you to use. Let me change this color. It's not the great color. But there we go. Something like this. Yeah. And now you can see all these really nice KNN lines and the nearest neighbor to each of these source and targets. Boop, boop. Awesome. That's all I have right now for this demo. We have about another 10 or 15 minutes. We're happy to stick around and answer more questions and kind of go from there. Sean?
Yeah, no, that's great. Let's see if we have any questions here or if we've relatively kept up with them. Okay, well, let's pop back over to the slides. And we just wrapped up the demo, so we'll do one last poll here just to say, would you like someone on our team to reach out to you? So I'll go ahead and hit this poll. And let's go back. And this is just if you want some follow-up with our team, you want to brainstorm solutions, you want to learn more, no obligation, just give an opportunity for us to reach out. Here's the QR code if you're on the live stream and you would like us to connect with you. And we'll give that another minute here just for everyone to answer. And this can be about Wherobots, this can be about the open source Apache Sedona, or even if just, what problems you have that you're trying to solve if you want to chat a little bit more with our team. Daniel, I was curious, anything that you especially like about that demo that you gave or that you found especially compelling? I personally, I like that we did that kind of two-sided analysis. If we started with just looking at the network quality, but then we added those towers, so there's kind of a so what or a next step
Yeah.
that you could run with.
I love the KNN join. I've written so many of those using Postgres. And I love Postgres. I love the PostGIS platform. I really do. But that and join, that cross-lateral join. If there's a better way to do it, I'd be love to hear it. But having that direct KNN join predicate is something that I'm a super big fan of it. It makes that analysis so much easier and that query so much easier to write and to understand. I think that's probably my favorite part of doing this whole one. And then you get to make these super cool, like, little arc map lines, not arc map, but that's a different platform. I guess more of the, let's turn those off.
Yeah, the little arcing lines going
Yeah,
from
they're so nice
out
to be able to
to
see and work,
location.
you know. I think that's probably my favorite part is the integration of the KNN lines and then be able to just like run and test this, right? Like if I wanted to do, 5 nearest neighbors, increase the distance here, right? So this is kind of a KNN join with kind of a maximum distance. So this returns the first two as long as you're within 1,000 meters here. And so that's something that we added to this that I think is a really great addition. The workflow would typically be, get my 3 nearest neighbors, but my nearest neighbor is on the other side of the ocean, right? Like that doesn't really help because frequently these types of relationships, while you're still looking for the nearest neighbor, it is distance bound. And this really truncates that part, that second part of that analysis. Give me my 3 nearest neighbors, now filter to everything that's actually within a reasonable distance that kind of matches my use case.
Yeah, yeah, definitely very cool. Cool. Well, I think that's everyone that's going to respond to the poll here. We, definitely down to still do some Q&A, so we'll take a look at that in a second, just to make sure I say all the things I need to say. If you are interested in trying Wherobots, you can sign up through the AWS Marketplace. We also have a free community tier edition for people to try it out. And we're, happy to chat with you if you want to reach out to me or Daniel.
Mhm.
And let's just do a quick check of questions and see. Okay, so I've got a couple of them here. Let's see. Do we support DBT?
I think not currently. That's should be on the way, if I remember correctly. That's actually something that we've been looking at as well. So
Yeah,
DBT.
I mean, we've been hearing about it all the time, and so I know it's I'm fairly certain it's on the roadmap.
Yeah. Yeah.
Let's see here. What's the next one? Will the introduction of a new GeoParquet version and its integration into Iceberg and Delta following replace Havasu and improve also the performance of the OSS Sedona through the usage of GeoParquet bounding boxes, etc.?
Yeah, I think that it's still kind of a little too early to tell if a full replacement. There's some other stuff that makes the implementation on our side a little bit more performant. And so, like, the interoperability, I believe, will be there, but whether there is still like performance enhancements that need to be kept in-house is, I think, kind of something that's still up for discussion. Support for the newer specs are already in the platform. Like those are things that we helped pioneer and help get into the spec initially. And those are fully supported currently within the platform.
Yeah, I mean, just as a company, we're big fans of advancing geo in Iceberg. I know a lot of our team were involved in getting the native geotype into Iceberg. Even though we do have our Havasu format that we use within the platform, we are trying to get more of these standards open source and as actual established standards for geospatial because it kind of just helps everybody. Cool. That's all I'm seeing here. Any closing thoughts, Daniel?
I'm good, man. Thank you so much for your guys' time. I really appreciate your attention.
Thank you all. Glad to have you on today and really appreciate the engagement from this group. There's a lot of comments and discussion and questions that were really fantastic. So thank you all.
Cheers.